This chip controls your car, stores data about what you bought, and runs the software on your laptop. These chips have come to power our lives, and only a handful of fabrication plants or fabs in the world have the know-how and infrastructure to make them. So most of the chips are produced outside of the US, like at this fab in Singapore.
To build a fab is a big investment.
And now the world is running out of chips because companies can't make them fast enough.
When order really flooding in, we had to turn on every single piece of machine that we can find in the factory.
The pandemic rattled supply chains and led to a surge in demand for electronics when people were stuck at home. While a perfect storm of natural disasters, a fire at one of the world's leading auto chip makers, and the ongoing US-China trade war disrupted the production and distribution of semiconductors. This shortage has affected whether you can drive a Jeep off the lot or buy a new PlayStation 5. We visit one of the world's largest contract chip makers to see the complex process and why there's no quick fix to the supply crunch.
Chip usually takes about 2 to 3 months to make.
Daniel Rajkumar is a manufacturing manager at one of the fabs at Global Foundries. The American company is the third largest contract chip manufacturer in the world. Companies like Intel, AMD, and Bosch give some of their circuitry designs to Global Foundries. And then its fabs like this one in Singapore manufacture the chips.
Once we finish the fabrication of the circuitry, it has to go for testing, it has to go for repackaging.
Altogether, it could take as much as 6 months before a chip is ready to go into your tech. This long process starts here, at the center of the fab called the clean room.
Before going into the clean room, we need to gown up.
Because chips can be as small as a fingernail and crammed with billions of components, they have to be handled with great care.
Any form of dust that falls onto the wafers, it will cause the chip to be defected. And then now we are able to go in through the air shower. Okay?
Global Foundries says this clean room is 1,000 times cleaner than an operating room. And it also takes up a lot of space.
2 footballs field, that's how big it is. We have about 700 to 800 machines.
It's also yellow in here because chips are sensitive to UV rays, and this lighting has none of that.
This is always the first step.
The starting material for any chip is here in this room. These super thin discs are called wafers and made from silicon. Eventually, one of these will produce about 1,000 to 1,500 individual chips. But before it does, the wafer is placed in a special container.
We have the raw silicon. We are now trying to register this material and transfer it into our wafer carrier.
Each carrier can hold up to 25 wafers, and there are about 4,000 of these moving around the facility at one time.
We are also the source of particles when we go into the clean room.
So never once during manufacturing does the wafer come in contact with any of the workers.
It will bring the wafers directly to the machine, and in this foundry, basically 95% of all processing jobs is fully automated.
These raw wafers are cleaned before starting a process that Rajkumar describes as similar to making layered cake.
The main function of a diffusion furnace is basically to grow layers of oxide or to dab a nitride onto the silicon.
That creates a protective coating. Next is a layer that makes the wafer light sensitive, so it's ready for one of the most important steps called lithography.
This is the most expensive module in any wafer foundry. The number of lithography machine will define how many wafers you can produce in a month or a year.
One lithography machine can cost anywhere between $25 million to over $100 million. And that's because it's responsible for adding layers of the circuitry, basically electronic components like transistors and diodes, that allow the chips to eventually store data or run apps.
What I'm holding here is basically a pattern design of a circuitry.
Inside this pink box is a photomask, which is like a glass stencil, and clients send these directly to Global Foundries. The lithography machine blasts UV light through the photomask and prints patterns on the wafer over and over again. The difference between an advanced chip for a 5G smartphone versus one for your credit card comes down to the type of wavelength that's used. Shorter wavelengths mean you can etch finer features and get more performance out of the chips. Some of these transistors are so small that they're measured in nanometers and compared to DNA strands. Once the circuitry pattern is imprinted, the wafer has to be charged.
These machines use a lot of energy to produce electrical charge that allows the electrical to flow through the chip and also creates the different type of function for your electrical chips.
Rajkumar says many of these steps are repeated hundreds of times before the fabrication is complete. And to get to this point, these orders have to be made at least a year in advance.
I have a demo wafers here to another.
The finished wafers are tested, then finally sliced into individual chips.
One is the small die wafers, which is mainly used for bank cards or chips. And then you have the other one, which is the bigger die wafers, which can go into other kind of applications like computer processing chips or electrical appliances.
GlobalFoundries says its fab in Singapore typically makes about 600,000 wafers a year. But with the recent surge in demand, it's making around 120,000 more.
This whole year is fully booked up. We don't have any more space for new customers.
Tan Yu Kwong is the Vice President and General Manager of GlobalFoundries Fab 7 in Singapore, and he says there's no quick solution.
There's no space that you can house another lithography tool or any other tools that you like to buy. It is a lead time easily 1 year to 15 months before you can see a tool that is coming into your factory.
It's not just a backlog of equipment, but Tan says expanding or building a fab from the ground up would require deep investments, more than the $1.4 billion that GlobalFoundries has already committed to spend this year on expanding its 3 fabs around the world.
You easily need to spend 7 billion to 15 billion depending on the size of the factory you want to build, and the technology that you're going to develop can easily take you decades to build the foundations.
So to fill as many orders as quickly as possible, the company turned on idle machines and opened this factory control tower. Engineers here have a bird's eye view of the entire fab, and the green boxes show which machines are running at max capacity. Before this control tower, when there was a problem, engineers had to sort through data and piece together information themselves.
Compared to today, just looking at the screen, you already know that this is a piece of machine. You need to pay attention now.
Tan says any time saved is precious, but to truly address the shortage, the company is working more closely with its clients, suppliers, and the government.
We're going to continue seeing more government support because it is becoming such an important part of the entire global supply chain.
There's no reason why Americans should wait. We're investing aggressively in areas like semiconductors and batteries.
The Biden administration has proposed $50 billion to boost America's chip production. That's because while the US is one of the largest semiconductor markets, the majority of the complex and expensive manufacturing happens at a few companies based in China and East Asia.
That's because the world's biggest foundry in the world, TSMC, is located in Taiwan. Samsung also has a sizable foundry, as well as some Chinese players.
This concentration of fabs means any disruption to the supply chain, like a drought in Taiwan or political tensions with China, can have big ripple effects, especially when global demand is expected to grow by more than 12% this year.
We have technologies like 5G and artificial intelligence, and these types of advanced technology means that more chips will be needed to operate the devices that we use every day.
To meet that demand, the Chip Industry Association says it will require an investment of $3 trillion globally over the next 3 decades. So for us to buy new devices, Tan says his fab will work around the clock as it turns this challenge into a business opportunity.
From the ambitions of wanting to grow the company, this is definitely a positive point for us. This over demand is going to be around for a while.